So, my name is David Jr. I work with Beckhart Environmental. You guys have seen me before. You can just introduce yourself.
Yeah, I'm Terry, corrugator superintendent.
Okay.
I'm Preston, I'm corrugator supervisor.
Joe Hernandez, single phase operator.
Okay. Thank you.
Leaving.
So I'm just going to go over the jar testing procedure for converting operations with physical and chemical wastewater treatment systems. Recent reviews of wastewater treatment operations have shown variations in methods used to perform a jar test. This training presentation has been prepared to show operators, supervisors, and/or management the basics of performing a jar test. Without a jar test performed for every batch, the operator cannot be sure of the exact chemical feed needed. Note, sites not performing jar tests have been shown to be spending more time on processing a batch of wastewater and spending more money on chemicals. So, I mean, if you don't know how much chemicals you're gonna add, people just kind of do it manually and chemicals can be off, you know what I mean? Like, I've seen people add way more caustic than they need to, pH will be too high, way more polymer, binding up the filter press, so it's good to have a good formula. The purpose. A jar test is a process to test a representative sample of wastewater to determine the approximate quantity of treatment chemicals required to properly treat the current wastewater. Optimizing chemical usage will save time and money for the site. The operator saves time by not operating by trial and error, and knowing the proper amount of chemicals to add saves the site money. All processed water generated at a converting site should be collected in an equalization tank. When the process is ready to begin the treatment phase, the water is transferred to the treatment tank. And I'm sure you guys are all familiar, EQ, treatment tank. So. However, before the water can be treated, the operator must know the amount of treatment chemicals to add so that the physical portion of the process can perform optimally. Required materials. You guys have a jar test kit. Basically, it comes with a pitcher, two 400 milliliter glass beakers, some pH paper. You guys don't use the pH paper, you have the Pros, so it's probably more accurate. Some gloves. I mean, we're dealing with chemicals, so caustic and coagulant, so it's good to wear gloves. You guys have the sink right by there and back in the treatment area, some paper towels, and a well-lit work area. Some equipment. Inline pH probe. This does a continuous read of the pH when the system is recirculating through this point. The reading is posted on a pH screen or on the control panel. Y'all are familiar with the pH meter? Yeah. Calibrate that every month. Sample collection port. During the recirculation step, you can collect a sample for your jar test from this point. You guys have that as well. Sometimes it gets a little plugged up, so if you want to grab the sample from the top, it's not a big deal.
I think that's where we're getting our samples from, right?
Yeah.
Top,
Yep. This is some pH buffer to calibrate your pH probe. And that's the pH paper, but you guys are using the actual probe, so. Alright. You should only collect the sample while the water is being mixed or agitated. Collect the water in a clean, non-contaminated pitcher or other type of vessel. Take the sample to the test area, which needs to be a clean, well-lit work area. It is preferable to have the chemical impervious sink with running water available. And you guys have that back there, so there's no problems with that. Okay, the first step is your coagulant addition. Take the collected water and pour a 100 milliliter sample into a 400 milliliter clear graduated beaker. Using this water as our small scale version of the larger treatment tank, we will begin the jar test. And we'll go through that once the PowerPoint's over. Add your coagulant, 0.1 milliliter at a time, and then stir. Keep track of your milliliters and watch for any action in the water. The key is to add the least amount of chemical and still get a good break. Keep adding the coagulant until you get a good break. And when it says break, you can kind of see the water basically emulsifying in that little sample container. You can just start seeing it break up, start seeing clear water around the edge. So just keep an eye out for that when you're adding your coagulant. After your coagulant addition, you should note a slight separation of solids from the sample. If you don't see a break or pin flop after adding 1 milliliter, that'll be a whole syringe full of chemical to 1 milliliter. That's a lot of chemicals. So if you're not getting a break, just throw it away and try again. Notice the darker spots inside the circle. I don't know if you guys can see that on the side. It's basically starting to flop. It's just really small. Okay, pH adjustment. Now this is when you add your caustic. The next step after the coagulant addition is to make sure that the pH of the water is in range. Typically you want to be between 6.5 and 8.5 for the best results and to be in compliance with the city's permit. I think you guys are between 6 and 10, so you have a little bit more of a window than that, correct?
Yeah, I believe so, right, Mark?
Yeah. Okay. Now our system will automatically adjust the pH through that pH meter. So as long as you keep that calibrated, the settings in there will have it where the caustic will go up to about a 7. So you guys should be good. As long as that probe is calibrated, you shouldn't have a problem with that. The last step is your polymer addition. Final step of the jar test is the polymer, which will help increase the size of the flock. I kind of like to compare the polymer to like fly paper. When you're adding that polymer and then you stir it, it kind of just goes around and grabs everything. It turns into a bigger flock. That flock will fall down and then the clear water will be on top. So, typically, you'll want to start off by adding 0.8 to 1 milliliter of polymer and check to see if you have big flock and that the water is clear. If not, continue to add 0.1 at a time until you get good results. If you get to a point where you have added 2.5 milliliters of polymer, discard the sample and start over. Because sometimes, for whatever reason, it just doesn't break. I've seen it before where I've added like 2 milliliters, and then I did another sample and it only took like 1.5 and it was fine. So for whatever reason, just sometimes you have to do 2 jar tests to get it good. And then this is what your final results will look like. I'm sure you've all seen that. So, I mean, we can go ahead and do some jar tests together. I don't know. I'll go ahead and do one, and then you guys can do it if you like. So basically, this is the 100 milliliter container. This is my dirty water that we got. Joe, have you done a jar test before?
I worked with him.
With Mark? Okay. So I know you two have,
Yeah.
for sure. This is the pH. Basically, I'll test the pH of my water first. Just right at about 8.55, 8.56. I think at this point we're dropping it down to about 5.5. So
5.7.
5.7. Yeah, so right around 5.5, 5.7. This is the first chemical, your Polymac. I recommend wearing gloves with this just because it's kind of acidic, exactly. So I've had it before where I've got some on my arm and I've wiped it off and my hair came out. And my hair comes off. So just as safety, wear some gloves. Same thing with the caustic too. I've got that on me. You get some burns on there. And the polymer, it doesn't really affect your skin, but water is what activates it. So if you're driving home and you get sweaty on a hot, sweaty day in Texas, kind of get slippery, your hands will be falling off the wheel. It's kind of, and then this, don't clean it up with water. If you ever spill this, get some sand or some kitty litter or something like that. So if you get water, you'll just have like a freaking ice skating rink.
Slide.
Yeah, ice skating rink. Alright, so I'm gonna start out. You know the pH is at about 8.5, so it says start out with 0.1 milliliter. Let's start out with 0.1. It's about 3 drops, a little bit more. Give it a good mix. looking for that break, but I don't see it breaking yet, so I'm gonna add another milliliter. You want to keep track. I'm just gonna keep track in my head, but you want to keep track of how much you add, of course. So
That's
at
what
the
you're
end,
gonna add.
exactly. At the end, you'll know. So now I can see it.
a little bit of it.
Yep,
right there.
you can see it from there. I can see it starting to come off on the sides a little bit. And I was only with 0.2. So I'll test my pH again. It only brought it down to about a 6.5, 6.6. So I'll probably add, since I know, I'll probably add 0.2 more, because it'll probably bring it down to that 5.7 range. Start up again. Now you can really start seeing it break up. I don't know.
You can see it on the sides
You see
where
it?
you tilt it, yeah.
See it from there.
Yep.
Breaking up. Start seeing it. It should be. Yeah, I'm only at about 6.9. It's breaking pretty good, so I mean, we might not need to add that much on this sample. It'll change from sample to sample too. Yeah, I'm sure
Yeah.
you can adjust your chemicals,
Right.
how much you need by the jar test, so. But yeah, I'm not even gonna, so I'm at a 6.9, I think I'll just add a little bit of caustic. Sorry. A little bit of caustic, bring it back up to 7. And all the caustic does is just adjust your pH. It doesn't do anything else. It brings the pH up. Be careful with that, because I've seen people at some plants, they'll leave the caustic switch in manual and they'll walk off, go do another task, and they'll come back and they pump the whole tote of caustic into that tank. And that brings the pH up. I mean, I've seen it at a 12 to a 14. Then they have to call a hazardous waste truck to come out and pump it. And that's going to cost you guys a lot of money. Yeah.
We've only had one batch here that I know of that's been
Yeah.
that high. We didn't.
It just happened at a plant in Fort Worth. He said that something malfunctioned, but
If you're right there,
yeah.
Yeah, that's why we don't leave when
And yeah, when you're adding those
when we're
chemicals.
doing the batches.
Yep. Oh yeah, I'm getting good separation, and I didn't even have to add that much chemicals.
Yeah.
Just be careful with this. It's kind of like snot.
Yep.
It's real sticky and.
And when you hit it with water, it goes everywhere.
Yeah, I think it's 1 quart of this is about, you mix 1 quart of polymer with 240 gallons of water. So I'm gonna start out I'll start out 0.8 with my polymer, yeah. And you can see it starting to break up right away. And I mean, I barely had to add any chemicals in this. The first 2.
so typically when that happens, Dave, is that typically it's more water than solids when you see that kind of stuff?
I
Or
mean,
is that more-
there's still a lot of solids. It's just for whatever reason, this batch, the inks that were used in production didn't need that much to make it break up.
Break it up.
Yep.
You see it start to separate
Yeah.
real good.
And then, so I mean, what I'll do from here is represent your filter press.
Right.
Just take a little funnel, and I'll just pour it. You'll see all the
There comes
clear
the
water
clean
come
water.
out, and
There you go. That's what we normally see in the filtrate tank.
then and you got all your solids on
That
top.
orange looking. There you go.
So That's basically jar testing 101. Without this, you really won't know how much chemicals to use in your 5,000 gallon batch system.
Same.
But
Exactly.
if you're doing that in automatic, you have to make those adjustments.
Exactly. So
Or whatever your dropper is, right, and then let it do its thing.
Yep. So what I did was I added 0.4 of my initial chemical, which equals 20 gallons. So you go to the PLC screen, type in 20 gallons, or if you're adding it by minutes, that pump will pump 5 gallons per minute. So you'll do 4 minutes. Okay, and I wrote the conversion sheet up for you guys. I'll hand one out to you guys before I leave. And then, but caustic is always by pH.
Right.
So it'll bring that pH up right to a 7.
Right, that does it on its own.
Exactly.
I mean,
It's just a polymer and the coagulant.
Right.
And the polymer we added 0.8, which is 40 gallons. So, I mean, really, you're only using about 60 gallons of chemicals for this batch.
For this batch, yeah.
Exactly. So, which is not bad at all. So, thanks, guys.